Hi guys, welcome to another video of Physics 2. In this case, we're going to start with the topic of friction, okay? So this is the first problem. So in this first problem, we got a surface. Over the surface, there is a block which mass is 10 kilograms. And this block is being pulled by a force of 90 newtons, okay? Now the interesting thing, well, before I mention the friction force, it's important to mention that, okay, the motion goes to the right and the block is going to move at constant velocity. And we're going to have friction force, and this is the friction force, okay? The letter that I use for friction force is the F, and it's like an italic an italic F, okay? It's not like this F over here. And there is a little K over here. And okay, the friction force is always opposite to the motion. So if you see the motion goes to the right, so that means that the friction force must go to the other side. In this case, will be to the left. Now there are two questions over here. The first question is the kinetic coefficient of the friction force, and the letter B is the friction force. Okay, before I start solving this problem, okay, there are two things. We're gonna have the kinetic friction force. Okay, this is the kinetic friction force, and we also are gonna have the static friction force. Now, what is the difference between these two forces? Okay, if the block is already moving, so that means that is we're gonna have a motion. There is a friction force that goes against that motion, and that will be this one, the kinetic friction force. If I'm going to start moving the object, in this case the block, but the block is not moving yet, so I'm gonna have the static friction force. So in this particular case, the block is already moving, so that means that I'm going to use the friction force, the kinetic friction force. Now, every friction force has a coefficient. So in this case, the kinetic friction force is going to have the kinetic coefficient, and this one is going to have the static coefficient. Okay, this is like a U, the letter U, but an italic. Okay, now this number is a fixed number. It's a number that goes from 0. It could be the static or the kinetic. It goes from 0 to 1. Okay, and it's a fixed number that does not have units. So if you can see here in this table, it's going to depend on the surface. I mean the object and the surface. So for example, here we got wood on wood, and we got the static friction coefficient that is 0.5, and the kinetic friction coefficient that in this case will be 0.3. Now it is important to mention that the static coefficient is greater than the kinetic coefficient. Okay, that's very important, and you can see it here in this table. This number is greater than this number is greater than this, and so on and so on and so on. So if you see, there is a table where we can see those values, and those values are fixed values. Okay, and I mentioned before, this coefficient does not have units. Okay, so in this case, what we're going to find, okay, we don't know the surface and we don't know the material of the block, so that's why we're going to find the coefficient and also the friction force. Now the formula that we are going to use is this one. The kinetic friction force equals the coefficient of the friction force times the normal force. Okay, so this is the only new formula that we are going to use in this problem. Okay, we're going to use many other formulas, but this is the only one that is new. Okay, so I believe that we can move on. So remember that all the problems are going to have the same structure. I got the drawing, then what I need to do is the free body diagram. So let's begin. Free body diagram, if you remember, is a Cartesian plane, and the x-axis of that Cartesian plane must be parallel to the surface or parallel to the motion. Okay, well, it would be something like this. This is x, this is y. In the middle, in the origin, I'm going to draw just a dot that it will represent a particle to simulate block. Okay, so let's draw the forces. Remember that there are always going to be a force that is not there, but we know that is there, and is the weight. Okay, and points to the center of the earth, and it's over here. That's the weight. And then we got the force, in this case goes to the right. This is the force. The kinetic friction force goes against the motion, so it goes to the left. Okay, and the normal force, remember that every time that we have a surface and the block is over, that is in contact on that surface, is perpendicular to that surface and opposite to the weight. Something like this. Oh, I forgot. The normal force, usually I draw it with green color. Normal force. And one important thing, remember that all forces must be in the over the axis. So all the forces you see are over the y-axis and the x-axis. Okay, so let's start with the analysis. Let's start with the x-axis analysis. Okay, x-axis. And remember that all the analysis we begin with this: the sum of all forces in the and in the axis that we are analyzing, in this case is x, equals how much is the block moving? Yes, but in this case moves at constant velocity. Constant velocity means that there is no change in velocity. No change in velocity means that there is no acceleration. Okay, so the formula force equals mass times acceleration. Well, no acceleration, so that means that the right side of the equation would be 0. Okay, so in this case it will be 0. Okay, so remember the reference system. In the x-axis there I got two forces, this one and this one. Everything that goes to the right is positive, everything that goes to the left is negative. Okay, so in this case I'm going to have force force minus kinetic friction force equals 0. Okay, in this case I need to find the friction force, or well, the first the coefficient. So minus kinetic friction force equals minus the force. Okay, so the kinetic friction force equals the force. So if you see, this question could be answered right now, because I need to find the friction force. In this case, the friction force equals the force. So in this particular case, the kinetic friction force equals 90 newtons. Okay, you can say, how is this possible? How this block could be moving? Okay, yeah, it's moving, but it's moving at constant velocity. That means that both forces are in balance, they are in equilibrium, because there is no acceleration, but there is constant velocity. And we don't know the constant velocity. I mean, that constant velocity could be 1 meter per second, 3 meters per second, or 0 meters per second. That's an interesting thing. So we're gonna see more problems about that later on. Okay, so then I'm going to substitute what the friction force is. So friction force is the the coefficient of the friction force times the normal force equals the force. So the coefficient of the friction force equals force over the normal force. Okay, I don't know how much is the normal force, so I need to begin my y-axis analysis. So let's do it. Y-axis. Okay, so let's continue with the analysis. The sum of all forces in y, in this case the block is not going to move in a vertical way. Okay, so it's in equilibrium, so that means that the sum of all forces in y is 0, 2. So I want you to look at this. Both axes, the forces are equal 0, so that means that the system is in balance, is in equilibrium. Okay, so normal force goes up, the weight goes down, so normal force minus weight equals 0. So that means that the normal force equals the weight. And for example, I can continue with this equation over here. So I'm going to substitute the value of the normal force. I'm not gonna do it with another color. So the coefficient of the friction force equals the force over the weight, because we already know that the normal force is the weight, and this will be force over mass times gravity. So let's get the calculator in order to find. The force is 90 fraction 90 over over mass times acceleration. Okay, so equals, how much is that? Okay, that is the coefficient of the friction force. Let's write it. Coefficient of the friction force equals, remember that this number must be between 0 and 1. and the greater the number, the harder is going to be to move that object. Okay, the harder the coefficient, sorry, the bigger the coefficient, the harder it's going to be to move that block over that surface. Okay, so for example, this we've got bone lubricated by synovial fluid. Okay, there is almost nothing, there is no coefficient. Okay, so I'm gonna write it. So in this case, it's going to be 0.9183. Remember that the coefficient does not have units, and this is letter A because I already found letter B. Letter B, this was the friction force. Now I repeat, these two are equal to 0, so that means they are in balance. We don't know how much is the velocity. The only thing that we know is that it's constant. Constant velocity could be 0 meters per second too, or 10 meters per second. The only thing that we know is that that velocity remains the same. Okay, so this was the first problem about friction force. I believe is a pretty easy topic, but the more variables and the different data that we have, I mean, we can have more different equations, and I believe it could be fun. Okay, well guys, I hope I can see you in the next videos, so take care. Bye bye.